video is intended to help a Math 135 student who is struggling with an optimization problem. The strategies we provide will make the problem look and feel less challenging. Even though this may seem menial in the problem-solving process, it's integral to a student's success, as many students, such as the one we're helping today, won't even begin a problem if it looks too difficult.
Some general steps for completing optimization problems include defining variables, draw diagrams when applicable, create an equation to represent the information given if this already isn't given to you, solve for the first derivative and find critical points algebraically, assess if the critical points are a maximum or minimum, and write a conclusion. The sample problem we will be working on comes from the week 9 of the Wiley Plus homework. The student is having difficulty starting because they notice that the equation has more than 2 variables and they've never done an optimization problem with more than 2.
In order to help the student ease their first qualms, let's define our variables. We've taken the definitions directly from the problem, and as you can see, C is simply a constant. Therefore, if the student is made nervous by the extra variable, we can simply remove it by substituting in C for another number. In this case, we made C equal to 5. This removes the portion of the problem that was preventing the student from beginning.
Now that we've created a way to break down the problem to look less daunting, we can continue with our problem solving. The next step in optimization problem solving is finding the derivative of the equation. So let's find it using the product rule. However, we could see that this derivative is very complicated, and our students don't think that they have the skills to isolate the variables in such a complicated equation. They start to panic, so we work with them to find out ways to make the equation look less daunting so they can continue. The strategy we came up with was simplifying the derivative, substituting C back in for 5 to give us a nice equation they felt comfortable doing algebra with.
Now we can begin to find the maximum and minimums of the graph by setting the derivative to 0. However, once our student sees that one of the maxes and minimums is a C, they begin to panic. We need to remind our student that it's okay to get an answer that's a letter. C is a number, it's a constant. Here, our strategy is to remind the student that when they see too many variables, to read the problem over a second time and remember what their variables are defined as.
Now that the student understands that C can be a valid answer, they should begin to test to see which critical points is a max and which is a min. There are multiple ways to do this, but today we'll use the second derivative test. We can find the second derivative and plug the x values of our critical points. If the value is less than 0, it's a max, and if the value is greater than 0, it's a min. When we sub our points in, we could see that the second derivative at 0 is C. So our second derivative is greater, so this is a min. And our second derivative at point D is equal to negative C, so this is a max. This is the value that we're looking for. This test lets us know that the dose that maximizes the temperature is the positive constant C.
In conclusion, here are some steps you can take to make your optimization problems look less daunting.